Hello, good evening. Today is April 29th, 2025, and this is a recorded presentation of a paper that I'm going to present at the IEEE Big Data Security Conference. And the title of the paper is on data-driven security. And the co-authors of the paper, myself, of course, Professor Latifa Khan and Professor Kankuk Ji. So I'm going to share my screen. Okay, so the presentation. So what I'm going to do is first briefly go through the presentation, and all of the details are in the paper. Okay, so again, the presentation is quite short, but I'll also go through the paper to discuss some of the various aspects. Okay, and so okay, so this is the presentation, and again, as you can see, it's a short presentation, and then we'll go through the details in the paper. An education program in data-driven security. And so it's actually, it's Bhavani Thuraisingam, so I'll let me correct it. Because when I do a spell check some other, instead of Bhavani, it shows up as Havana. Okay, so okay, so this is a short project that we carried out a couple of years ago, and we are still working on it. And it's about developing various courses. Some of the work is sponsored by the National Science Foundation and various other agencies for these education programs, but this particular one has been our own work, not sponsored by anyone else. And what is data-driven security? What we really mean by that is that to educate, conduct experiments, we have to collect data. So data is collected at every step of the process. And based on the data collected, we conduct security analysis, as you will see. And that's what we mean by data-driven security. And it is at all levels: systems, networks, IoT. Those are the ones we are focused on so far, but there's also the cloud and databases and the World Wide Web and cyber physical systems, regardless. So whatever we are explaining in this paper, it could be applied to a number of systems. So our education program covers topics, and it's again based on data science, machine learning / AI for traditional applications, host and network security, as well as emerging domains, Internet of Things, industrial control systems, and enterprise security, with carefully curated contents and hands-on activities based on industry guidelines. To keep the course tuned to the rapidly evolving threat landscape, the program includes a plan for an attack lab that will continuously accommodate and exercise the latest attack vectors and tactics, techniques, and procedures. We also discuss a capstone course in data-driven cybersecurity that consists of multiple modules that would utilize the lab. Our plan is for students to learn not only about the attacks, but also the viable solutions to the different paradigms. So, so this is sort of our lab composition. So I'm going to briefly talk about this, and the paper goes into all the details. So course modules and lab composition. So we have a number of modules, I believe 8 modules, and how they flow into each other. So first, introduction to host and network security. Remember, everything is guided by data. So, and the paper talks about what are some of the various components. Then we also, data science is an important aspect, data science / machine learning. Then we go into host security and malware analysis and network attack and defense. And then, of course, protecting the IoT, advanced persistent threats and attacks, graph analysis and learning. All these attacks are put into graph form, and then we develop a fully fledged production system. That's the whole idea. So we have this cyber kill chain and hands-on lab assignments. So action on objectives. So every step of the way, right? First you talk about various aspects. Okay, so first you have to do the reconnaissance, discovery, and then the initial access, weaponize, and delivery. And then, of course, we have to exploit and install. So that's defense evasion, and we have number of labs. And then command and control. And of course, what's the impact? Action on the objectives. So again, data is being collected at every step of the way, and based on the data, we are developing solutions. Okay, so that's the whole idea. Now, here we show the malware lab, especially this is the lab of Dr. Kankup G, who is a co-author of the paper. So we've got this malware lab, the IoT test bed, right? So it's Internet of Industrial Control Systems. And then we conduct these experiments. We have a sandbox 1, sandbox 2, sandbox 3. And then, of course, our enterprise test bed and the user zone and server infrastructure zone. So various zones, we put it all together. It's sort of an industrial control system lab. And we are collecting malware and then looking at simulating these attacks, everything in a very, very controlled environment. Okay, so what are the modules that we have developed? Okay, so first module is, or we are developing, I should say, Introduction to System and Network Security. Of course, this is something that we have, completed. And it's, again, what are various, this is sort of a first level course, System and Network Security. But again, we are incorporating the data-driven security into this paradigm. Then Introduction to Machine Learning, host security and malware analysis. And then we talk about networks, attacks, and defenses, protecting the Internet of Things. And we combine everything and talk about advanced persistent threat attacks. And then module 7, how to use graph representation and embedding. And then these production systems, build a complete production system. So that's the goal. So integration, okay, so we have these various modules, and all of these modules combined is our capstone course. But some of the modules, we are using it into our current courses. So for instance, the host security and malware analysis can go into our course on system security and malware analysis. Okay. Then our network attack and defense goes into advanced network security. And then, of course, protecting IoT, we have, and this particular class I teach, secure cloud and IoT securities. So that's a class I teach. And APT attacks, that feeds into big data security and privacy. So our education program in big data security and privacy, I talked about that particular program last year at the last year's Big Data Conference. And this year at the Big Data Security Conference, we have another paper on blockchain, education program for blockchain. And this is the education program for data-driven security. And again, introduction to ML basics feeds into multiple course modules, and graph analysis and learning also into multiple course modules. But again, remember, these individual courses on the right-hand side, they cover a lot more. So these 8 modules that I describe here is our capstone course. But each of these modules could be taught in other classes, and that's what we show here. And my last slide for here, and then I'll go through the paper, is we have discussed a program plan and data-driven security with machine learning applications. While we have developed parts of this plan and incorporated them, our current courses, into our current courses, we are in the process of developing the capstone course. So that hasn't been done yet. For example, attacks to big data and machine learning, as well as to the cloud, and potential solutions have been introduced to our cloud security and IoT, as well as attacks to big data security and privacy. While we continue with developing the various course modules, we are also focusing on new applications. We've got a large project on transportation system security, which is an aspect of cyber physical system security. And again, over the last year and a half, we are really focusing on applying LLMs, large language models, of course. That's sort of the big thing now in AI, machine learning, for cybersecurity. So how can we use LLMs for cybersecurity? We can use LLMs for answering questions about various regulations, answering questions about various threats. So two things are really central to some of our current work: LLMs and the MITRE ATT and CK framework. And they are being explored to be incorporated into the course modules. And so this is the presentation, but what I would like to do is also just go through our paper. Okay, so the paper is this one here. Okay, where is our paper? Sorry. Paper is, data-driven security. And I just want to go through the paper. Okay, education program. And by the way, this is the early version we submitted, and the final version, has got, is completely sort of a more edited version. So of course, introduction, we talk about why are we doing this? Why are we doing data-driven security? Okay, so right, so that's again what, and our approach to an education. So approach to education is capstone curriculum integration. So again, the whole idea is to develop a capstone course, number of modules. Each module can be taught separately in other courses, aspects of the module. Okay, then we talk about realistic attack reproduction with the attack lab. So we have got the labs, and with this lab, we can develop realistic attack, and then we can reproduce these attacks. That's where all of this data is for the attacks, for the various malware. Okay, so we are conducting a lot of research. What's the relevant? Traditional host network defenses, that's one area. Another area of research is security research in emerging domains, right? IoT, cloud, and so on. Cybersecurity, this is cybersecurity with ML, a lot of work in that area. And now, curriculum development. Our approach, again, is to develop the curriculum, a number of modules for the capstone course, and each one will correspond to, it can be applied to some of the other courses that we are teaching, like cloud security and IoT security and so on. So let's see. So we have attack cases for a lot of hands-on labs, dataset collection, and attack test beds. So that's really crucial. And then course module development. So module 1, introduction to system network security. And each course has got labs. So DP1 is the lab for module 1. Module 2 is introduction to ML and MLIDS. Lab 2A is for module 2. Okay, module 3, host and network security. And so here we have lab 3A, 3B, 3C. So a lot of labs. Module 4, network attacks and defenses. And I talked about it again, number of labs. Module 5 is cloud and IoT. Right, so where is module 5? Yeah, so it's cloud, IoT. And again, with module 5, protecting the IoT, a number of labs for module 5. And then like lab 5A, IoT device identification and profiling. Okay, so we describe the labs in detail. So module 6 is advanced persistent threat attacks. And so, for instance, 6B is automated causality analysis, finding the root cause for forensic support. Module 7 is how do you represent? So in this module, we will discuss the approaches to build a model using system events represented in the graph structure, the various events that happen. Fine. And then 8 modules, remember. So module 8 is production system. The course concludes by discussing the practical aspects to implement and deploy ML-based security to a production. Contents and labs for this module are designed to introduce and explore practical issues that would arise as one applied ML-based security approaches to real-world production environments like event stream processing. So the one module lab 8A, scalable online monitoring. 8B, interpreting the alerts. 8C, prioritizing the alerts. 8D, model maturity. Students will review their implementation for Lab 5B, federated learning for deep neural networks, to devise an indicator for the ML model maturity by measuring the progress of the model update over time and the data and network reduction gained by having more IoT devices reported to the cloud. And then, of course, extensions to existing courses, which is what I mentioned earlier, are big data security course. I teach both developing and securing the cloud and IoT. Okay, so summary and directions. We have discussed program plan for data-driven security with machine learning applications. While we have developed parts of this plan and incorporated them into some of the current courses, we are now in the process of developing the capstone course. For example, attacks to big data and machine learning, as well as the cloud and potential solutions, have been introduced into our current courses. While we continue with developing the various course modules, we're also focusing on applying LLM, also heavily using the MITRE, ATT, and CK framework. Okay, so NSF has supported not this particular capstone, but various other projects like cloud, big data security and privacy, and also courses like developing mobile applications, and in particular also blockchain and AI and security. And okay, so I think, let's see. So I'm going to stop sharing. Okay, so let me still share this screen, I think. Okay, so, right. So as I said, this particular course, again, data is crucial. We have to collect data for any analysis. And in this particular case, we are collecting threat data, data about various malware, and again for systems, networks, IoT, cloud, and eventually we'll go into transportation like cyber physical systems and more we are also focusing on industrial control systems, but we'll also go into like transportation systems and so on. So, okay, I'm going to stop sharing, and that's the end of my presentation. And again, looking forward to seeing you all at the conference. Of course, these are regular papers, so they are not going to be presented at the conference. It's going to be online. And so looking forward to seeing you all. And again, thank you very much. And I'm going to now stop the recording.